Now we're going to factor those polynomials. So you've got to know all those things. GCF, trinomials, difference of squares, and cubes. So we have a trinomial with a leading coefficient of 1. So we just say what multiplies to get 24 and adds to get 11. And of course that's 3 and 8. The order does not matter. This one, that's the difference of two squares. You should know that 9 times 9 is 81. The next one is just like the first one. We have a coefficient of 1. So we say what multiplies to get 14, adds to get negative 9. And that would be negative 7 and negative 2. Now number 45, whoa, that's not anything like the first three. I've got to look for that GCF. What do they both have in common? They both have a 3x. So if I divide both by 3x, that's going to leave me x squared minus 9. But that's the difference of two squares. So I should know that x plus 3 times x minus 3. But don't forget that GCF. 46 is just like 42. We have a leading coefficient of 1. What multiplies to get 8 adds to get 6. 47, same thing. What multiplies to get 28 adds to get 11. Again, what multiplies to get negative 27 but adds to get a negative 6. So we got a negative and a positive, negative 9 and positive 3. And whoa, here comes 49. We do not have a leading coefficient of 1. This is where everybody teaches it differently. You could have learned a box method, a grouping method, a bottoms-up method, a trial and error method. You do it the way your teacher has taught you or the way you feel most comfortable. The way I do it is I go, what can multiply to get 6? What can multiply to get 2? And I kind of start guessing. So if I try 2 and 3, I know my 2 can't go with the 2, so I put the 1 there and the 2 there. And I'm just going to try it out. So this is 3x, that's 4x, that is not 11x. So I know that is not right. So I'm going to try again. And I know that the 2 and the 3 can't work again because the only place that 2 could go was the 3. So now I'm going to try the 1 and the 6. And the 2 can't go with the 6 because they have a common factor of 2. So I'm going to put the 2 here and the 1 there. And that's 12x. That's 1x. If I make that negative and that positive, I'm going to get negative 11x. Same thing for number 50. So 5 is 1 and 5, 6 is 1 and 6, or 2 and 3. I'm just going to try. And since 7 isn't very big, I'm going to try the 2 and the 3. So that's 10x. That's 3x. If I make that positive and that negative, that should work. So that's positive and that's negative. I got lucky. The first thing I tried worked. If it didn't, I would have rearranged and kept trying. Again, number 49 and 50, you may have seen a different way, but our answers will be the same. On 51, you've got to look for the GCF. They all have an x. Then 51 is kind of like 49 and number 50 in that we've got to try some things for 6 and try some things for 10. I'm going to try 2 and 3 for 6, and I'm going to try 2 times 5. And I know the 2 can't go here. That's the most common thing. But you know what? That's 15, that's 4, that doesn't give me 7. That doesn't work. Okay? So 2 and 3 doesn't work. So how about 6 and 1 with the 2 and 5? And again, I can't put the 2 at the 6, so I'll try that. That's 5x, that's 12x. If I make that negative and that positive, that works. Were those my only choices? No, but I got one that worked. 52, 53, and 54, I have 4 terms, so I need to use my grouping technique. So I'm going to group the first two and the last two. What's the GCF of the first two? 3x. They're both divisible by 3x. And so if I divide, I get that. What's the GCF there? I think a 5. So if I divide by 5, now this is where you know you can keep going. That matches. So that's their GCF. So divide those out, write down what's left. Group, GCF is an x. Here they're both negative. I think they're both divisible by -5. Those match. So take that out, divide, write down what's left. What's this GCF? Ooh, how about a 4x squared? And that's going to leave me 3x minus 7. Do those have anything in common? Not really, but it almost matches that. Since you have that negative, let's factor out a -1. If I divide by -1, that's going to change those signs. Now that matches. Again, divide that out, write down what's left. But this time I'm not done, because that is the difference of two squares. A little bit harder. Now we have cubes. Again, your teacher may have taught you with a formula, with a saying. Just kind of depends. But you have to recognize that those are cubes, and all of cubes have a binomial, two things, multiplied by a non-factorable trinomial. So here, this is going to be x minus 5, keep the same sign, and then I teach it as square this, multiply, take the opposite, and square the last one. So this last sign is always positive. I do square, opposite, square. On 56, let's see, I have 8x cubed plus 27. So my short one looks just like this, except I need what makes an 8x cubed, 2x, and 3 cubed is 27. Then I square this, multiply, take the opposite, and I square this. SOS. Again, your individual teacher may have taught you different methods, which are fine. We all end up in the same spot. These are quadratic equations that we're going to be solving by the factoring method. You need to set it equal to 0. We need to factor, and we need to set each factor equal to 0 in order to solve. So number 57 already has that very important 0. So we're just going to factor, and we're going to look for that GCF of 2x. Then you set each factor equal to 0 and solve that resulting linear equation. So dividing by 2, here we're going to add 4 and divide by 5. So we have two solutions. Number 58 doesn't have that 0, so we're going to need to distribute. Then I'm going to subtract 3x and add 3 to get that all-important 0. Then I can factor. So what multiplies to get 15 and adds to get 2, a positive 5 and a negative 3. Then set each factor equal to 0 and solve. And again, we have those two solutions. Number 59 looks just like 57. It has the 0. We're going to look for the GCF. This time they just have an x in common. So we set those both equal to 0. So that one's done. Here I need to add 5 and divide by 9. Number 60 looks just like 58. So I need to distribute. Then I'm going to subtract 2x and subtract 6 from both sides. Again, getting that all-important 0 before I can factor, and that's because of the zero product property. And then set each factor equal to 0 to solve. So I get x equals -7 and x equals to +3. So again, quadratic equations, we're looking for it to set it equal to 0, then we're going to factor and set each factor equal to 0. These next three problems talk about reducing the rational expression, which means we're going to factor. So how do we factor here? GCF of an x. How do we factor that? A trinomial. What multiplies to get -6 and adds to get 5. Be careful, this one's kind of tricky. It's not 2 and 3. It is actually +6 and a -1. Now we want to reduce. We want to reduce out common factors. Number 62. We're going to factor that. Pretty easy. 3 and 1 is it. That's the difference of two squares. Then we reduce out those common factors. Number 63, factoring that. Let's see. -5 and -3 multiply to get +15, add to get -8. On the bottom, again, we've got to get that -1. So this time it's 2 and 3, and it needs to be a -3 and a +2. Those are your common factors that divide out. So we have x minus 5 over x plus 3. Do I need the parentheses? No. I could have put them here. I could have put them here. You can always be safer using parentheses.